In this video, we'll show you how to implement secure agent workloads that use MCP. One current approach is to deploy a centralized MCP proxy. This proxy acts as a managed entry point for all agent traffic, allowing policy enforcement across MCP servers. Importantly, it works without requiring modifications to your remote MCP servers. Our goal is to implement controls that support least privilege and mitigate risks like token theft and data exfiltration. The foundation begins with identity and adherence to least privilege. First, establish a unique identity for the agent recognized by Google Cloud IAM. If using agent identity instead of a service account, note the difference. The agent principal is cryptographically attested and auto-provisioned with the agent's runtime, ensuring it cannot be impersonated. Second, secure the credentials used for accessing MCP tools. The MCP servers providing access to the tools may aggregate high-value authentication tokens. Store necessary tool credentials such as API keys in Secret Manager. See our video on securing ADK agents using Secret Manager to learn more. The link is in the description below. Third, enforce least privilege. Use IAM conditions to grant the dedicated service account access to Secret Manager, but strictly limit it to only the specific secret version required for its task. Principal Access Boundary, or PAB, allows administrators to define an absolute ceiling of resources an agent is eligible to access, providing maximum containment against overprivileged agents. Fourth, centralized authentication. Depending on the architecture, the MCP proxy functions as the point of authentication for the MCP servers. It validates the agent's identity consistently using the Google Identity Platform and passes the credentials we covered earlier in Step 2. We use layered security controls to harden the deployment environment. Deploy your MCP server on a confined platform like Cloud Run or GKE. Using a managed container-based approach limits the need to worry about OS-level security. For data exfiltration protection, enforce VPC service controls, or VPCSC. Draw a security perimeter around sensitive Google Cloud resources that the MCP tools access. You can also use global load balancing with Cloud Armor to provide DDoS and web application firewall protections against common OWASP web threats at the ingress point to the proxy. For data at rest, you can enforce customer-managed encryption keys, or CMEK, for all sensitive Vertex AI assets, including models, datasets, and endpoints. The final layer of defense is the inspection of all content flow, applied at the platform level. We use the new Model Armor Vertex integration to provide AI guardrails. The administrator can simply turn on Model Armor to apply security policies without making any changes to the application code itself. Model Armor inspects content at 3 critical points: the user prompt, the tool call request, and the tool call response. Model Armor strictly filters tool call requests to prevent command injection or remote code execution. This blocks malicious inputs before they reach the downstream tool. Model Armor uses its sensitive data protection filter on the tool call response. This mitigates data exposure by redacting unintentional leakage of PII or other sensitive data from tool results before they're passed back to the LLM. See our other videos on how SDP can be used with the agents and AI workloads. By implementing this comprehensive defense strategy, your agent ecosystem is secured against core threats. Please be sure to see the links in the description for more videos, architecture, examples, and documentation. In our next video, we'll go over how to monitor configuration and automate detection for MCP-based workloads. We're always diving deeper, so please comment in the video what you want to see next. Thank you for watching.